Good afternoon, students. Today the topic is definite integral, and we will start with properties of definite integral. Before that, we will start with the definition of definite integral, that is second fundamental theorem of integral calculus. So second fundamental theorem of integral calculus, which actually you know what it is, and you have been using this through your 11th class as well as your 12th class. In this particular theorem, we study that if any function is there, fx, which is continuous, and we are taking integral from a to b fx dx, and this is continuous in the interval a to b, continuous in the interval a to b. Now when we integrate this function from a to b, we get a function capital Fx, which is actually an integral of a small fx, which we were doing in indefinite integral. And when we put the limit from a to b, we write it like this: fb minus fa, and this value is actually the value of integral a to b fx dx, which is the second fundamental theorem of calculus. The thing which we have to keep in mind while applying this is that this function fx is actually continuous in the interval. So if in any case the function is not continuous, then you cannot directly write it like this. For example, we take a question, this one. This is integral 0 to pi dx upon 1 plus 2 sine square x. Now in this particular question, if we go as a simple way of integration as we were doing in indefinite integral, and we'll just put the limit. So what we'll do here, 0 to pi, this would become cos square x plus sine square x, that is the value of 1. And that sine square x, when added with 2 sine square x, will become 3 sine square x. And this would become dx. This would become integral. Now let us divide by cos square x in the numerator as well as in the denominator. So this would become sec square x dx upon, this would become 1 plus 3 tan square x, right? And the limit is actually 0 to pi. Next, you know that if we take tan x as t, then what would happen? If we take tan x as t, then its derivative is sec square x. So that would be dt. So 1 plus 3 t square. And the limit is 0 to pi. Later on we will back substitute t as tan x. So we are not changing the limit. This whole thing just we'll discuss later on. Right now we are not putting the limit as well. And we are saying that this would become, in the next step, 1 upon 3 dt by 1 by 3 plus t square. Now this is the direct formula of 1 by a tan inverse x by a. So this would become 1 by 3 into a square is actually 1 by 3. So 1 by a means 1 by root 3 into tan inverse of t by a, that is 1 by root 3. Next what we will do, we will say that this would become, after cancellation, root 3 tan inverse, and this t is actually tan x. So this would become tan x and this would become root 3. Now our standard process, if we put the limit here, that is x limit is 0 and pi, upper limit is pi and lower limit is 0. Then what would happen? This value would become, in case of pi, tan pi is 0. That means tan inverse 0 is also 0. This would become 1 by root 3 0 minus, when you will put x equal to 0, then also this would become 0. So this is 0. So this value is 0. But this is a wrong calculation. Why this is a wrong calculation? The value which we have integrated is tan x. The integrand was this 1 by 3 plus t square, in which t is present, and t is actually tan x. So if this integrand tan x is not continuous, and it is actually not continuous from 0 to pi in this interval, where it is not continuous? At pi by 2. pi by 2 tan is not defined and it is discontinuous always, even it is not in the domain pi by 2. So in that case we cannot do this. This is a wrong calculation. So what we could have done here is a piecewise integration, which we will study as a property later on. Right now we have to just understand this is what we have done here is not right. In piecewise integration, what we do actually, that we can split from 0 to pi to 0 say pi by 2 and pi by 2 say pi, and then we can put the limit from 0 say pi by 2 and then pi by 2 to pi. So in that way there won't be any problem. So we will rediscuss the right method of this question when we will do that property. Right now I hope it is clear that why this calculation is wrong, because by second theorem of calculus, integral calculus, second fundamental theorem of integral calculus, the function, that is the integrand, has to be continuous in the whole interval a to b. Now I would come to geometrical interpretation of a function. So what is geometrical interpretation of a function? In case of an integration, definite integration, geometrical interpretation is area under the function or the curve fx. So if we talk about a function fx, small fx, and then we take the limit from a to b, this is x, this is fx, and we say that integral from a to b fx dx, what does it mean? So this actually means the area which this function is making from a to b with the x-axis, and actually this is an algebraic area. What do we mean by algebraic area? Right now it is clear that this area is a to b fx dx, but if in case the function is like this, this is your a and this is your b, what do you mean by fx dx from a to b? Does that mean this area plus this area? No, actually this means algebraic area means whatever this area is, this area we are taking as positive because it is above the x-axis, and whatever this area is, we are taking actually negative in case of integral a to b. So this area and this would be in negative. So in case if you get this area as 2 and if you get this area as 5, then what would be the integral a to b fx dx? That would be minus 3. 2 plus minus 5, that would be minus 3. So algebraic area could be negative as well because it is below the x-axis, and you can see that below the x-axis area is more than the above the x-axis area. So when you will take below the x-axis area, it would be minus 5, and above the x-axis area will be plus 2. So overall value will be minus 3. If we will study later on in area under the curves, there we will come to know that if we have to find the area under the curve, then instead of algebraic area we take absolute area. So that is a thing which we are going to do later on. Right now we should know that this is actually an algebraic area. Let us take an example which can more appropriately help us in understanding the concept of algebraic area. So we are taking a function fx which is actually minimum of mod x 1 minus mod x 1 by 4 for all x belong to real number. Then what will be the value of minus 1 to 1 fx dx? Fine. So first of all, minus 1 to 1 fx dx, the function is not a simple one defined single definition function. This may change depending upon the interval, because in some interval mod x may be lower, has a lesser value than 1 minus mod x. Sometimes 1 by 4 may have a lesser value. So you don't know which value is lesser. So we have to simply draw the graph right now. So what we do here, we draw the graph. Let us draw the graph for all the three functions. One is mod x. Mod x between minus 1 to 1 is, this is your minus 1, this is your 1. And mod x between minus 1 to 1 is a function like this. This is actually mod x. And this value is 1. And 1 minus mod x, if you remember graphical transformation, how do we plot 1 minus mod x? We first plot mod x, then we take its negative. So negative of this is actually a graph like this, and then we add 1 to it. That means we shift it upwards by distance 1. So this would become like this. This would be the function. This is actually 1 minus mod x, and this is actually mod x. Blue one is mod x and black one is 1 minus mod x. Next we have a constant function 1 by 4. And where this 1 by 4 will come? This point is actually half. Midway, you can even calculate it, but anyhow it will come half. And this is actually half. A little non-symmetrical figure it has been drawn, but it is symmetrical from both the sides. And 1 by 4 is a line which is below half and above 0 in between both of them. So this would be the line 1 by 4. So this is y equal to 1 by 4. So overall minimum of these three graphs, if you draw between minus 1 to 1, so this would be the minimum of these three graphs. This part, then this part, then this part, and similarly here you will go like this. This would be like this, this would be like this, this would be like this, and like this. This is the graph we have. And when we want to find the integral from minus 1 to 1 fx dx, what we will do, we know that this and this is same. So this actually means that this is twice of 0 to 1 fx dx, we can say. And again the function is different. From here to here it is mod x, then here it is 1 by 4, there it is 1 minus mod x. So if you want to integrate, you can integrate. But there is a simpler method, as we know that this integration means the area under this curve, algebraic area, and the area under this curve actually is area of the trapezium. So this is twice into area of the trapezium. So this would become 2 into, what will be the area of the trapezium? Half into sum of the parallel sides. So this is actually 1, and above line is actually 1 by 2. Actually this part is 1 by 4, right? And this part is also 1 by 4. This is 1 by 4 and this is 1 by 4. So the upper part is, length is 1 by 2, 3 by 4, sorry. 1 by 4 more than half and 1 by 4 less than half. So the length is actually 1 by 2. Sum of the, and height is actually 1 by 4. I hope it is clear to everyone. The area of this trapezium half into sum of the parallel sides into height, and the sum of the parallel sides is 1 plus half the smaller side and multiplied with the height, that is 1 by 4. This value would become 3 by 8. So overall answer for this question is 3 by 8. So this is, you have applied geometrical interpretation of definite integral and just found the area, algebraic area. Next what we can do is, we can start properties of definite integration. So two things we have done till now. One is second fundamental theorem of integral calculus. Actually you were wondering what is the first fundamental theorem of integral calculus. So we will deal that one also later on. That is actually also called as limit of sum. And That is actually the first fundamental theorem, but today's class we are not dealing with that. We are now coming to properties. Properties of definite integral. So first property as in is interchange of dummy variable. So we have a to b fx dx can be written as a to b ft dt. This variable is x, which is a dummy variable, that is also called limit of element of integration, can be changed with another dummy variable t. That won't affect the value of this definite integral, because in the definite integral this dummy variable doesn't is not present at the end. The value is present. That is, we don't get answer in terms of x, we get answer in terms of the value. So whether it is x, whether it is t, it doesn't matter. This will also give you capital FB minus capital FA, where capital Fx is its integration, and this will also give you capital FB minus capital FA. So it doesn't matter which variable you are using for integration. Second property that we have to discuss is a to b fx dx can be written as minus b to a fx dx. That is, you can interchange the limits and take a minus sign here. So this is called interchange of limits. So when you see here why this minus is coming, simply because you are taking from b to a, that means the integration is not going from left to right. If you are taking a smaller and b is greater, here the integration is from left to right, here integration is from right to left. So the minus sign would be like you are taking the base in the negative direction, negative x-axis, and we know this is an algebraic integral. So algebraic area. So algebraic area do have negative sign as well. So that is why its sign is coming as negative of what we get as a to b. Another explanation could be this is actually fb minus fa, as you can see here, and this is minus of fa minus fb. So that would obviously be fb minus fa. Third property, a to b fx dx. This is actually called piecewise integration. We can write it as a to c fx dx plus c to b fx dx. So when we talk about c here, so c is not necessarily a value between a and b, it can be outside a and b as well. So if you take it like this is a function fx, and you are saying that this is a, this is b, then if you are taking c here, then it is quite obvious to you that this whole area from a to b is same as area between a to c plus c to b. But even if this point is outside somewhere on the right or on the left, then also there is no problem. Like if this function is going till here, extending till here, and we have to find the area, this one. So in that case, what is a to b fx dx integral is a to c fx dx and plus c to b fx dx. So what will happen? This c to b is actually negative of b to c. So this would get cancelled. So a to c area will cancel this area and you will eventually get this area. Another one is by definition. This is fc minus fa, and this is fb minus fc. In any case, fc would get cancelled and you will get fb minus fa. Fine. So this is actually the integral from a to b fx dx. Now let us see, based on one thing we can also do. The question which we left there, that was we were doing a non-continuous function integration. Now if we would have done there piecewise integration, instead of 0 se pi we would have written as 0 se pi by 2 plus pi by 2 to pi. in this particular interval, open interval, it is continuous. It is no problem, you can take open interval as well. Here it is also pi by 2, it is to pi, it is a continuous. And what we got there was 1 by root 3 tan inverse, if I remember, root 3 tan x. This is what I think we got there. And here we got 1 by root 3 tan inverse root 3 tan x. And when we put the values here, so what will happen? Tan of pi by 2 is actually infinity, tending towards infinity. Root 3 multiplied is infinity. Tan inverse of infinity is pi by 2 again. So can we write it as pi by 2 root 3 minus, this would become your 0, plus, what will you do here? Tan inverse, this whole thing will become 0, minus you will put pi by 2 here, and this will become again pi by 2 root 3. So you are getting 0 or not? You are also getting 0. So is it right or wrong? It is again wrong, because when you are putting pi by 2 here and saying that it is infinity, how can we say at pi by 2 it is infinity? It can be infinity, it can be minus infinity, because you can approach pi by 2 from left hand side as well as from right hand side, as we studied in limits. If you remember, this is your tan x and this is your tan x, this is pi, this is 0, this is pi by 2, and this is what you are doing. Now if 0 say pi by 2 you are taking, then this would become 0 to pi by 2 minus. I hope it is clear to everyone, because maybe the answer would be 0, because this area and this area would get cancelled, algebraic area, but the way which we have calculated it here is not right, because we cannot say pi by 2 is infinity. Pi by 2 can be infinity, can be minus infinity. So and if the answer may be different, you have to just see, because it is an inverse function. So overall condition may change. Let us see. So pi by 2 minus is a value which is infinity. Now this would become infinity, and tan inverse infinity is pi by 2, which means this value is okay. No problem with this. What would happen with this value? When you will take यहाँ पे pi by 2 plus, because the function is continuous from pi by 2 plus to pi, not from pi by 2 minus to pi. If you would have taken pi by 2 minus to pi, then again it would have become discontinuous at exactly pi by 2. So you have to take from pi by 2 plus to pi, then it is continuous. So we have split it from 0 say pi to 0 say pi by 2 minus, and then pi by 2 plus to pi. And then we have got the value of 0 to pi by 2 minus as this. What will happen from pi by 2 plus to pi? Let us see. So if we put pi, this would become 0, this is 0, fine. Minus, when we put pi by 2 plus here, this tan pi by 2 plus will be a value which is minus infinity. Now tan inverse of minus infinity is a value which is, tan inverse of minus infinity is a value which is minus pi by 2. If you remember inverse trigonometric function, there we take the principal value region from minus pi by 2 to pi by 2, excluding them. So but we are putting the limiting value here. So the limiting value which we put here is actually not this pi by 2 minus infinity. Instead of that, minus pi by 2. Tan inverse of minus infinity, that is the catch in this question. Tan inverse of minus infinity is actually tending towards minus pi by 2. That means when you will take this as minus infinity, tan inverse of minus infinity will be minus pi by 2, and there is a subtraction minus would be here, then this would become plus. The answer would become pi by 2 root 3 plus pi by 2 root 3. That means pi by root 3. This is the right answer, and don't think that this area is cancelling, because this area is obviously cancelling, but question is not this. Question is not 0 say pi tan x dx. What is the question? 0 say pi 1 by root 3 tan inverse root 3 tan x dx. This question is different from this question, because here there is an inverse trigonometric function. This may create a graph which is very different from the graph which we have drawn here. This graph which we have drawn here is for the assistance to find the limit. Okay. So this is a question which can clear your concepts of discontinuous function, limits, as well as the values which you have to put. The answer for this would be pi by root 3. That means the value which we are cancelling throughout everywhere. In the last part also, here also we cancelled this 2. Just because we took pi by 2 as infinity. But this is a wrong concept because pi by 2 is not defined. When you are seeing pi by 2, you have to say that we are approaching pi by 2 from left hand side or right hand side. If we are approaching pi by 2 from left hand side, then only this part will be continuous, and then we will take it as plus, and when we are approaching from pi by 2 plus, then it is minus infinity, and if it is, in case it is minus infinity, then its limiting value is minus pi by 2, because tan x has a principal value from minus pi by 2 to pi by 2. So in that case you won't get here pi by 2, you will get minus pi by 2. So negative of that would get added up and you will get the answer like this. I hope it is okay with everyone. Fine. Now let us come to questions which we want to discuss based on these three properties which we have studied just now. So first question which we will discuss here is x cube minus x mod minus 1 to 2 x cube minus x mod dx from minus 1 to 2, and here again there is a mod function. We don't know where we have to eliminate this mod with a plus sign, where we have to eliminate this mod with a minus sign. So what we'll do, we'll draw in rough by wavy curve method its graph. So this can be written as x into x square minus 1, which is actually x into x minus 1 into x plus 1. And then we will say that this is 0, this is 1, this is minus 1, and the graph would be like this. If we take right side value, then it is positive, here it is negative, here it is positive, here it is negative. This is a graph like this. And when we say that we have to find the integral from minus 1 to 2, 2 would be somewhere here. We have to eliminate the mod from minus 1 to 0 as it is, because it is already positive, the value inside we can see here. From 0 to 1 it is negative. So what we will say, from 0 to 1 it is negative. So we'll eliminate mod with a negative sign, so minus x cube minus x dx, and then we'll say from 1 to 2, so this would become plus 1 to 2 x cube minus x dx. I hope it is clear to everyone. Wherever we see that the value is negative, we have to eliminate mod with a negative sign, otherwise we have to eliminate mod with a positive sign. This would become x to the power 4 upon 4 minus x square upon 2 from minus 1 to 0, minus this would become x to the power 4 upon 4 minus x square upon 2 from 0 to 1, and then we will get plus x to the power 4 upon 4 minus x square upon 2 from 1 to 2. Right. Now just put the values and get the answer. You will get, this would become 0, this would become 0, the limit which minus, I hope it would be done by you, na? Later on you will put minus 1 in, and here 1 and 0 and 2 and 1, you just find the answer. So you should get the answer of this question. Next, again another question we are taking, x square greatest integer of x dx. So in this one again a limit is given from 0 to 2. Again here x square is not creating any problem. Greatest integer of x, you already know that in question it has to be mentioned that this square bracket stands for greatest integer function, then only you will take it as a greatest integer function, otherwise it means a simple bracket. So it is mentioned here, it is a greatest integer function. And what you will do next is, you will take it as 0 to 1, because greatest integer function in consecutive integers is a constant. From 0 to 1 you can take x square greatest integer of x dx plus 1 to 2 x square greatest integer of x dx. This is what you will do. Next you will do, what is the value of greatest integer of x when x is from 0 to 1? If 0, actually greatest integer value by definition would become 0 because its lower value is 0 between 0 to 1. So this would become 0 to 1 x square, this would become 0 dx plus 1 to 2 x square, this greatest integer would be 1, the value between 1 to 2, so this would become 1. Now when you will write it, this would become 0 obviously, and this would become x cube upon 3 from 1 to 2. So this, when you will put the values, this would become 8 by 3 minus 1 by 3, that would become 7 by 3. Another question based on above three properties. 0 से 10 pi tan inverse x greatest integer function dx. This is what you have been given and you have to find its value. Now here 0 से 10 pi, the value of x is from 0 से 10 pi and the function is tan inverse x greatest integer. So you have to first draw the graph of tan inverse x. What would be the graph of tan inverse x? The graph of tan inverse x, as you remember, in inverse trigonometric function we studied it like this. This was the graph of tan inverse x, where x is actually the value and tan inverse x is the angle. So the angle here is pi by 2 and the angle here is minus pi by 2, which is never achieved. You keep going to infinity and here you keep going to minus infinity on the negative x axis. So here x is not the angle, though it is written as an angle 10 pi, but it is a value, that is 10 into 3.57, 3.14. So 10 into 3.14, it is 31.4 approximately. So they have written from 0 to 31.4 tan inverse x greatest integer function integral. So here when you will take 0 here, and what will happen to 10 pi? 10 pi is a value which approximately is 31.4 somewhere here. This is 10 pi, and when this value is pi by 2, this value is actually approximately 1.57. That means from 0 to 10 pi, the value of tan inverse x is from 0 to 1.57. Somewhere in between it has become 1. Where will it become 1? This value, which will become 1, will be at, no, again this will be tan 1, not pi by 4, because pi by 4, when you are saying x, again you are taking x as an angle, x is not an angle, the x is a value. So that value is tan 1. Tan and tan inverse will cancel, you will get 1, and that value you will get as 1, right? So you have to understand this thing, that x here is not an angle, it is a value, and the graph also says this x axis is a value, this y axis is the angle, and this is 1 radian. Okay, 1 radian, that means you can say that is, this is pi by pi. When pi is divided by pi, you get 1. So that simply means that this is actually 180 degree, which you say pi. When you divide this 180 degree by pi, that is 3.14, that would be approximately 57.16 degrees. If you remember, 1 radian is approximately 57.16 degree. We don't have to worry about those things, trigonometry part. But if you want to understand further, you can think like that. This 1 is a radian. And then what we will do? We know we can split it into two parts, from 0 to tan 1, tan inverse x dx plus tan 1 to 10 pi tan inverse x dx. I hope it is clear to everyone, na? So this would become when you will put tan inverse x from 0 to tan 1, the value of this integrand, this is actually the integrand, this integrand will lie between 0 to 1. When it would be tan 1, this would become 1. So in that case, you can say that its greatest integer function is actually 0. The value between 0 and 1 is 0. So this first function is 0. Plus, we talk about second one. So what is the second? Tan 1 to 10 pi. And we know that this integrand, here again we have to denote it like this, that tan inverse x is actually between 0 to 1. So its greatest integer is 0. And here when we will say that tan inverse x here what it is, so we will say that tan inverse x is actually between 1 to 1.57. This is what we will say. So 1 to 1.57 values, greatest integer is actually 1. So this will be 1 dx. What would be the final value? 10 pi minus tan 1. This would be answer because its integral would be x, and you will put the limit 10 pi minus tan 1. So this would be the answer, 10 pi minus tan 1. Next we come to property 4. Okay, let me explain it again. Okay, there is a question there also, how tan inverse 1 is 1, right? So tan inverse 1 is not 1. The right question, the question which is tan inverse tan 1 is actually 1. So let me again explain this whole process what we were doing. We were taking integration from 0 to 10 pi of greatest integer of tan inverse x dx. Now when we talk about greatest integer of tan inverse x, first we draw the graph of tan inverse x. The graph of tan inverse x is like this. This is the graph of tan inverse of x, and this graph actually has the output from minus pi by 2 to pi by 2, not including them. Okay. Now when we talk about the limit of x from 0 to 10 pi, we are saying that this x is actually a value, not an angle, obviously, because here tan inverse x has been taken. That means in inverse trigonometry we know that x we take as a value, and when tan inverse is applied on them we get an angle. So this 10 pi cannot be confused with an angle. This is a value. Everywhere this pi is here in radian. This is approximately 3.14 value. We can take it like this, and we can say that this limit is from 0 to 31.4 on x axis. Simply there is a number 31.4 which we are taking, approximate number, and then we are saying that this tan inverse x from 0 to 10 pi, we have the output from 0 to pi by 2. Now what will happen to tan inverse x greatest integer? It will be either 0 or it will be either 1, because it is not greater than 1.57. Obviously it cannot be greater than 2, then only it could be 2. Now I am saying that this value is from 0 to 1 in the interval 0 to tan 1, because when you take x as tan 1 here, then tan inverse and tan you can cancel, because tan 1 is a value which is in the principal value range, and then you can get it as 1. The output will be 1. So you are saying that if you take 0 to tan 1 as x, you are getting the output tan inverse x greatest integer from 0 to 1. And when you are taking tan 1 to 10 pi, this interval, then you are getting tan inverse x greatest integer, tan inverse x value in between 1 to 1.57. Instead of, you could have taken a 10 pi, 20 pi, 1000 pi, 2000 pi, any value. You could have got simply this here and simply this here as the answer, because it is any infinity. If you go till infinity, this is not crossing 1.57. So its greatest integer is anyhow 1. So if we talk about tan inverse x greatest integer, it would be 1 in this interval. You will get 1, and then interval is tan 1 to 10 pi. This greatest integer is 0, and then you will get this as x from tan 1 to 10 pi. So this would become tan 10 pi minus tan 1. I hope it is clear to everyone. Right. Now let us come to property number 4. So you have to understand these conceptual questions. Then it is like these questions are the backbone for your many other questions which you are doing. So when we talk about property 4, this would be integral a to b fx dx equal to a to b f of a plus b minus x dx. And this is also written as its corollary, that if it is 0 to a fx dx, this can be written as 0 to a f of a minus x dx. A plus 0 is actually a minus x. Let us take a question based on this. There is an integral pi by, we can go to in the proof of this as well, but I think you may do it by its definition. So I'm not going into that. We are discussing question based on this property. Root over sin x by root over sin x plus root over cos x dx. Now again, by the property, this is the integral which we have to find. By the property which we have just studied, this is a and this is b. If we add a and b, we'll get pi by 6 plus pi by 3 as pi by 2. And we will write wherever we find x here as pi by 2 minus x. So this would become pi by 6 to pi by 3 root over sine pi by 2 minus x by root over sine pi by 2 minus x plus root over cos pi by 2 minus x dx. I hope it is clear to everyone. Next, in the next step, this would become pi by 6 to pi by 3. Sin 90 minus x will be cos x. So this would be root over cos x. This would become root over cos x. This would become root over sin x dx. And this is also I. So when you add both the i's, you will get 2i. And what will happen? This I plus this I, this also I. So this would be 1. When you will take the LCM of this function and this function, the LCM is same. And then in numerator, you will get root over sin x plus root over cos x. That will actually become root over sin x plus root over cos x upon root over sin x plus root over cos x dx. And these both will get cancelled. You will get x. And the limit is actually pi by 6 to pi by 3. And pi by 3 minus pi by 6 is actually pi by 6. So 2i is actually pi by 6, which means I equal to pi by 12. So next question which we can deal on the same question, the concept is minus pi to 3 pi and log of sec theta minus tan theta d theta. Now this again we take as I, and what we do again by the property minus pi 3 pi, and what will be the addition of this? 2 pi. So wherever there is theta, you will write it as 2 pi minus theta. So this would become log of sec 2 pi minus theta minus tan of 2 pi minus theta d theta. What is sec of 2 pi minus theta? That is actually same as the cos behaves. So that would become sec theta, and tan of 2 pi minus theta is actually minus tan theta. This would become plus tan theta d theta, and this is also I. Equal to sign is everywhere. So if we add these two i's, we'll again get a condition like this. 2I equal to minus pi to 3 pi, and add these two. So the log, the value inside the log will get multiplied. So this would become log of sec square theta minus tan square theta. And what is sec square theta minus tan square theta? That is 1. And log 1 is actually 0. So whatever the limit you will put, it doesn't matter. You will get 0 eventually. Again, last question based on this property. X sin x from 0 to pi upon e की power x plus 1 dx. This is again I. What we do here? Pi minus x, as we are doing the property. 0 to pi, pi minus x, sine pi minus x. Okay, one thing you can do here, 0 to pi. This would create a problem because it is e to the power x. No, it has to be minus pi to pi. Question is wrong written there. It has to be minus pi to pi. It cannot be 0 to pi. Okay, maybe 0 to pi can be integrated, but we don't know. Again, there is a problem with unknown questions. We cannot take any integration and just integrate it unless it is authorized. It is minus pi to pi. Fine. E की power x plus 1 dx. So when you will add both of this would become 0. And this would become minus pi to pi. This would become minus x sine 0 minus x is obviously minus x upon e की power minus x plus 1 dx. This is what we will do. Now this will become minus pi to pi minus x sin x. Sine is a odd function, so minus will come outside. E की power minus x will become 1 by e की power x, 1 plus e की power x, and that e की power x will give in the numerator. Do you understand why it cannot be 0 to pi? Because if you put here pi minus x, it would become e की power pi, which will go nowhere. Okay, you cannot do normally that question, or I don't know, in worst situation it may not be done. So 2I equal to, you will just add these two functions. So this would become minus pi to pi, and denominator is 1 plus e की power x. So when you will add this one with this, you will take common as x sin x, and this would become 1 plus e की power x dx. Is this okay? So this 2 will get cancelled. You will get x sin x dx minus pi to pi. The value of this one is 2I equal to minus pi to pi x sin x dx. Now you remember how we integrate this x sin x. We did it in indefinite integral. This will be done by partial fraction or by parts. By parts, because partial fraction is different thing, na? That is a by a minus x plus. So this would become first function. Which will be the first and which will be the second? This would be the first and this would be the second by the Eilert rule. And then we'll say first function integral of this is minus cos x, minus integral derivative of this is 1, and integral of this is minus cos x again, and dx minus pi to pi minus pi to pi. When you will put pi here, this would become minus, let us take minus outside, pi cos pi will become minus 1, and minus pi, that would become plus pi, and cos of minus pi is actually cos of pi, that is minus pi again. I hope it is clear to everyone, na? This is what we will get here. You just put the limit, you will get pi, cos of pi is minus 1, this will be minus pi, and when you will do the same thing here, you will get actually plus pi, and there is a subtraction sign here, so this will become minus pi. Plus integral of this is sin x, so sin x from minus pi to pi you will do, and this is going to be 0 because sin pi is also 0, minus pi is also 0. So this value will overall 2 pi, and therefore I will be pi. This will be the answer which you will. Now we come to property number 5. So we have done 4 properties till now. First property was dummy variable property. Second property was change of limit, upper limit and lower limit. Third property was splitting from A to C and C to B. And fourth property was A to B is A plus B minus X. Now we come to fifth property. Fifth property says 0 से 2a fx dx can be written as 0 से a fx dx plus 0 से a f of 2a minus x dx. This is how you can write this. And there is a corollary to this property as well, that if f of 2a minus x is equal to f of x, this f of 2a minus x is f of x in this interval 0 to a, then you can say that 0 to 2a fx dx is actually 0 to a 2 times of fx dx. And if f of 2a minus x equal to minus fx in this interval, so this both will get cancelled and you will get 0 to 2a fx dx as 0. I hope it is a corollary. If you remember this one, you can understand this corollary. Now again we can do a question. If you try, you can prove this. It is not a very difficult task to prove these properties. Let us prove this one if you want. But you do 0 to 2a fx dx. In the next step, you take it as 0 to a fx dx plus a to 2a fx dx. By which property? Third property. And then we can write, this first one is as it is. Then we can write 0 to a fx dx. And let us substitute x as 2a minus x. So 2a minus t. So let us substitute this x as 2a minus t. So when we substitute x as 2a minus t, there will be change everywhere. So in limits also, that as such dx would become minus dt. When x equal to a, t would become a again, and when x equal to 2a, t would become 0. So this would become 0 to a fx dx, and this again, this is a to 0. So you can do one thing by property 2 plus 0 to a f of 2a minus t dt. Now which property? First property, that you take dummy variable t or you take dummy variable x, it means the same thing. So in this 0 to a fx dx and this 0 to a f 2a minus x dx. So using the previous properties, we can prove the further properties. Similar was the case with the property 4. In this one again, when we try to apply this property in the questions, like we get I equal to 0 to 4 pi dx by cos square x into 2 plus tan square x. So in this case again, if you see, this can be written as 0 to 2 pi, and one thing you can do, instead of applying that property, you can see its corollary. What will happen if you put x as 4 pi minus x? So this will become again cos x. 4 pi minus x will become cos x, and tan of 4 pi minus x will become minus tan x, but here it is a square, that will make it tan positive. So there won't be any change. That means in corollary part, the first thing is that twice of 0 to 2a can be written as 0 to a twice dx upon whatever the integrand is, that is written as it is. Okay. Then again 0 to 2 pi, half of that is pi. We again apply 2 pi minus x everywhere. Again the result is same, the same integrand we will get. So we can write it 4 times of 0 to pi dx upon cos square x into 2 plus tan square x. I hope it is okay. Next, this would become again will pi minus x. So what will happen? Cos pi minus x will be minus cos x, but there is a square, again there won't be any change. So we can again write it 8 times of 0 to pi by 2 dx upon cos square x into 2 plus tan square x. Fine. Now we can integrate. The integration is not as such difficult here. 0 to pi by 2 cos square x, its reciprocal is sec square x dx upon 2 plus tan square x, and this part would be integrated easily, its derivative is there. Now why can't we do this upfront here? Why can't we integrate this as sec square x and just do the integration and put the limit 0 and 4 pi? Because the function which we are integrating involves tan x, and tan x from 0 to 4 pi is not a continuous function. So you can't do that. Second fundamental theorem of integral calculus, you cannot apply the putting up of limits and integrating and everything. So you have to reduce it from 0 to pi by 2. Now in this interval tan x is actually continuous. Then you don't have any problem in applying this. You can apply. You can get the answer, you can apply the limits, and you will get the final answer. Now there is a famous result which is being used at many places. You can solve it as a question as well, because first time it was a question, but later on it became a result. That result is 0 to pi by 2 log of sin x dx and 0 to pi by 2 log of cos x dx is equal to 1 by 2 pi log half. This is a result. Now if you want to prove this result, either you prove this one or this one, same thing. So let us take I equal to 0 to pi by 2 log of sin x dx, and a to b property, again you will write it as 0 to pi by 2 log of sin 0 to plus pi by 2 is pi by 2 minus x. When you will do, it will become cos x dx. This is I and this is also I, both are I. Let us add them. What will happen? 2i, and when you will add these two quantities, they will get multiplied inside the log. So log of sin x into cos x dx, this would become 0 to pi by 2. Multiply by 2 and divide by 2. When you divide by 2 and multiply by 2, this can be written as half of sin 2x dx. This can also be written like this, sin 2x upon 2. Then just apply the formula 0 to pi by 2 log of sin 2x dx minus, and this would become 0 to pi by 2 log 2 dx. I hope it is okay with everyone now. And next it would become log of sin 2x. Again here you can take 2x as t. So what will happen? This would become log of sin t, and when you will say 2 dx, that would be dt. So that means dx would be dt upon 2. And when 2x is t and x is 0, what is t? 0. When 2x in 2x, when x is pi by 2, what is t? Pi minus, and here you take log 2. Integral of dx is x, rest is pi by 2 minus 0. This is pi by 2. And what would happen? Log of sine t dt from 0 to pi. This is sort of same question again, but it is not 0 to pi by 2, it is 0 to pi. So what you will do, you can again split it from 0 to pi by 2 and pi by 2 to pi. So this would become half 0 to pi by 2 and log of sine t dt plus one more thing, you can directly apply the corollary. If you see pi minus t, what would be that? Sine of pi minus t, that would be sine t. So can you say 0 to 2a can be written as twice of 0 to a, whatever the function is there, that is it. Because if you split it 0 to a and 0 again by that property 0 to a and 0 to f of 2a minus x, you will get the same thing. So this would become minus pi by 2 log 2. And again by the first property, change t by, this 2 will get cancelled, t by x. So what will happen? 0 to pi by 2 log of sin x dx minus pi by 2 log 2. I hope it is okay with everyone. And what is this? This is I. So I minus pi by 2 log 2. And this whole thing is actually 2i. So when you will take this I on the left hand side, the value will be I. Therefore I equal to minus pi by 2 log 2, which is actually pi by 2 log half. Next property is based on the concept of odd and even functions. So first property says that if fx is an even function, let us take even function first, then in the interval minus a, but overall obviously even function means it is even overall. So minus a to a fx dx is actually twice of 0 to a fx dx. And if we say that fx is an odd function, then in that case this value becomes, if it is an odd function, this value becomes 0. Why we write it like this? It is because we have, if we take the help of graph, we can do again both the methods, graphically and by analytical method. If we take the help of graph, what is an even function? Even function is a function which is symmetric about y-axis. So if you take a function like this, let us say this is a function, symmetric about y-axis. This is your minus a, and symmetrically here it is a. And you have been asked what is minus a to a fx dx. You will say that it is 0 to a fx dx ka twice, double of that. And if it is a odd function, it is an odd function, so you can write it, this is a function, they are odd, it is actually symmetric about origin, as you remember. This is a function and this is minus a and this is a. So both the areas will cancel each other because both are algebraic area, negative and positive. So you will get a value which is 0. Now we come to property 2 of this. You can prove this analytically as well. You can try it as homework, proving it analytically. But I hope you understood the concept of this even odd function, its integration from minus a to a. Second property says if ft is an odd function, then a function phi x from a to x ft dt is an even function. Again, a is some constant. This x is the final limit whose function this function phi x is. This x would vary, and this ft is dependent upon t, and it is actually a ft is an odd function, and obviously in the final answer t won't be present because the limit is a and x. So they are saying that phi x is actually is an even function. So what we will do here, in order to prove this statement, when we have ft an odd function, what does it mean actually? That f of minus t is actually minus f of t. So if it is an odd function, which means that f of minus t is actually minus f of t. This you keep in mind. Now let us proceed. What about phi x calling an even function? Phi x calling an even function means phi of minus x is actually phi of x. Fine. So if we take phi of minus x, what will happen? This will become a to minus x ft dt. Okay, we'll proceed it like this. Then what we do, we take t as a variable. Let's take it as a variable minus u. So if we take t as minus u, this would become f of minus u, and d2 will become minus du. When the limit t is a, what would be the limit of u? Minus a, and this minus x would become x. I hope it is clear to everyone. This would become minus a to x f of minus u du. It's okay. And then we are saying that f of minus t is minus ft, as it is a odd function. We can also say f of minus u is minus fu, whatever we want to say. Odd function means this. That means f of minus u is actually minus fu, means this minus would vanish, and we will say it is minus a to x fu du. Now still it is not phi x, it is minus a to x, and this is actually a to x ft dt. This is a dummy variable, this anytime we can change, but this minus a is creating a problem. Again, what we do, we split minus a to x from minus a to a fu du plus a to x fu du. Now you can get to the answer. As f is an odd function, minus a to a integral of this odd function will be 0. Symmetrical about origin, both the areas will cancel. This would be 0, and rest the function which remains is actually the same function as phi x. You can change this dummy variable u by t. So this will phi x, and we get the answer that phi of minus x is finally phi of x. That means it is an even function. Similarly, you can prove that if f of t is an even function, then phi x, again defined like this, is a odd function. This you can take as a homework. Integral of an even is an odd, and odd is an even, if it is written like this. Let's take a question. Minus pi by 2 to pi by 2 and log of a minus sine theta upon a plus sine theta d theta. And it is also given as a greater than c. So this is I equal to minus pi by 2 to pi by 2 log of a minus sine theta upon a plus sine theta d theta. And what you can do in the next step is, you have to check this is a odd function or even function. First thing you will do like that, because the integral is of the form minus a to a. So you have a common approach that you check this odd or even. That will make the final calculation easier. So when you will take the function f theta. This is actually log of a minus sine theta by a plus sine theta. And then you take f of minus theta. What would be that? Log of a sine of minus theta is minus sine theta. So this would become plus sine theta, and this would become a minus sine theta. Obviously, this is what we'll get. When you take negative power, this will become reciprocal. This will become minus of log of a minus sine theta upon a plus sine theta. This is actually minus, and this value log of a minus sine theta upon a plus sine theta is f of theta. So f of minus theta is actually minus f of theta you are getting, and that means this is a odd function. You don't have to do any calculation. The answer is 0. Next property which we have to deal with, definite integration of periodic function. Again, the concept is one, but the way in which this concept is expressed are 4, and you can also make it 5, 6, whatever you want to make it. But the basic concept is that in a periodic function, the function actually repeats itself. Now if I give you a function like this, this is a mod of sin x function. Mod of sin x is a function which is actually like this, from 0 to pi, 2 pi, 3 pi, and this is minus pi, and this goes forever on the right hand side and the left hand side. Now when I say that integral from 0 to 4 pi mod of sin x dx, and you know that mod of sin x is a periodic function with fundamental period as pi. Its fundamental period is pi. After every pi it repeats itself. So can't we say that is 4 times of 0 to pi mod of sin x dx? Why we will keep it calculating everywhere? Again, same thing will come because it is periodic. Area will also be same, periodic function area. So based on this concept, we can write few results. First result is, if it is 0 to nt, n is an integer, t is the fundamental period of the function, fx dx. So can we say this is n times of 0 to t fx dx, because t is fundamental period of fx and n is a integer, negative or positive, whatever it is an integer. So in that case we can always write it like this. Second result you can write like this. If it is not 0 to nt, it is from a to a plus nt fx dx. This can also be written as 0 n times of 0 to t fx dx. I hope it is okay with everyone, na? Because a to a plus nt is same as 0 to nt. If you see this graph, instead of saying 0 to 4 pi, if I would have said pi by 6 to 4 pi plus pi by 6, that means if you have not calculated this interval here, but you have calculated in the rightmost part, overall is same as 0 to 4 pi. If you add some constant to lower limit as well as above upper limit, that doesn't make any difference. So same thing is here, a constant has been added both in the lower and upper limit. It means again the same thing. Third property again you can express. Third property is mt to nt fx dx. Now it is again periodic function with a fundamental period t, m, n are integers. So can we say that this is n minus m 0 to t fx dx? If this is 0 mt to 0 and 0 to nt, then eventually this would be this nt मतलब 2 pi to 5 pi. ठीक है, तो that is basically 2 pi to 5 pi. There are 3 intervals. So you can say that 5 minus 2, that is 3 here, rest 0 से pi. Fourth property, a plus nt to b plus nt fx dx. Now here what the change is, nt has not changed, but the constant is different. So this is actually a to b fx dx as it is. Now if we talk about questions based on this, let us take 2 questions based on this. Question number 1, 0 to 100 x minus greatest integer of x dx. Another question I will give you as a homework. This is 0 to 100 x minus greatest integer of x dx. This would become 0 to 100 x minus greatest integer of x is actually fraction part of x dx. And if you remember the graph of fraction part, this was like this. And it is a periodic function with a period 1. So you can say that 0 to 100 can also be written as 100, 0 to 1, fraction part of x dx. And then we can write it as 100, and fraction part of x is a triangle. You even don't have to calculate it, you just see the area which this triangle is making. Half into base is actually 1, and height is also 1. So this would give you 50 as the answer. Final one more question, you can write it as a homework and you can do it later on. Find the value of 0 to 16 pi by 3 sin x mod dx, and the value of this is 21 upon 2, which you should get as the answer. So these were some of the properties of definite integral. There are properties of definite integral which are with inequalities as well. So that we will discuss in the next class. The equalities properties of definite integral has been over. Thank you, class.